Okay, I'm back. So I'm going to, I guess I'll optimize out this make file so I would never need to touch it. Let me ask, can you give me suggestions to optimize that make file?
Can you give me a suggestion to optimize that make
I
file?
do not want to touch it at all. Just set it up and forget.
Essentially, I do not want to touch it at all. Just set it up and forget.
Vertex shaders, fragment shaders, vertex beans, fragment beans. So I guess I'll take this part from here. Right. So shaders. Oh, that's cool. I think I would do it shader C. Shader C. So this is the building shader C. I guess I'll just so we make it depend of this and depend of that. Fragment beans. Fragment beans. So this is building shader C. Okay. So now do that, I think. Yeah, I guess Set the bin gears. That would be a good idea, I guess. Bins gear. Shader platform, Linux, shader profile, 430. Okay. Bin gears. That's cool. Let me see if it's gonna do any good things. So let's delete that, delete that, and go inside here, delete that, and see, revert this. Let's see. I'm thinking my microphone is too loud, so maybe I should okay, F5. So this is capture, microphone capture, 1 2 3 1 2 3 1 2 3 1 2 3 1 2 3 1 2 3 1 2 3 1 2 3. I think so. I can just hold the microphone very close to my mouth. 1 2 3 1 2 3, like this, right? And we can make this swing quieter. Do 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 pa 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 pa. Cool. Okay, let's see if it's gonna work. If we will have triangle. We've got the triangle. Yay! Okay. Let's me. So now we can go back to the tutorial and let's go to, so everything here is taken care of. Shaders, dimension, shaders have written. So types has like our own type, vectors. Okay, so this is like talking about shaders, uniforms, attributes. Okay, so go to the straightforward. Okay, so they saying we can do uniforms. Uniforms, so manage. I guess can we make it a bit smaller? Try to draw two triangles next to each other using gel draw arrays by adding more matrices to your data. So, okay, let's let's draw two triangles. Hello triangle. I guess we can do try list 1 and try list 2. Or maybe we can do vertices 1 and so like we can do minus 0.25 and we can do plus 0.25. Okay. And we can say VBH1 1 1 1, VBH2 2 2 2, and we can have them like these. VBH 1 2, and we can say this one, and then I think that would do. Interestingly, state, so we need to set the state all the time. So I need to set the IBH as well. That's interesting. But you know, this is why we are doing exercises. Okay, shaders. Chapter 5.
As mentioned in the previous chapter, shaders are little programs that rest on the GPU. These programs are run for each specific section of the graphics pipeline. In a basic sense, shaders are nothing more than programs transforming inputs to outputs. Shaders are also very isolated programs, in that they're not allowed to communicate with each other. The only communication they have is by their inputs and outputs. In the previous chapter, we briefly touched the surface of shaders and how to properly use them. We will now explain shaders, and specifically the OpenGL shading language, in a more general fashion.
This is text-to-speech is kind of cursed. Let me try to fix it. Say selected. Custom pronunciation. Result. Replace the function to replace all occurrence of substring case insensitive as for search. So I think that would do. Let's try it again.
As mentioned in the previous chapter, shaders are little programs that rest on the GPU. The subprograms are run for each specific section of the graphics pipeline. In a basic sense, shaders are nothing more than programs transforming inputs to outputs. Shaders are also very isolated programs in that they're not allowed to communicate with each other. The only communication they have is via their inputs and outputs. In the previous chapter, we briefly touched the surface of shaders and how to properly use them. We will now explain shaders, and specifically the OpenGL shading language, in a more general fashion.
Yeah, this was not right. I guess I should do like this. Okay, let's try again.
Shaders are written in the C-like language GLSL. GLSL is tailored for use with graphics and contains useful features specifically targeted at vector and matrix manipulation. Shaders always begin with a version declaration, followed by a list of input and output variables, uniforms, and its main function. Each shader's entry point is at its main function, where we process any input variables and output the results in its output variables. Don't worry if you don't know what uniforms are, we'll get to those shortly. A shader typically has the following structure.
Okay, this is fixed. So I'm pretty happy with how it's done. Filter out.
Filter out new lines.
Okay. Okay. Types.
GLSL has, like any other programming language, data types for specifying what kind of variable we want to work with. GLSL has most of the default basic types we know from languages like C: int, float, double, uint, and bool. GLSL also features two container types that we'll be using a lot, namely vectors and matrices. We'll discuss matrices in a later chapter.
One, two, three, 1, 2, 3, 1, 2, 3. 1, 2, 3, 1, 2, 3, 1, 2, 3. 1, 2, 3, 1, 2, 3. I think it's good. Vectors. Oh my. Great. I lost my spot. 5, 6 vectors.
A vector in GLSL is a 1, 2, 3, or 4 component container for any of the basic types just mentioned. They can take the following form and represents the number of components. Vecin, the default vector of n floats. Bvecin, a vector of n booleans. Ivecin, a vector of n integers. Uvecin, a vector of n unsigned integers. Dvecin, a vector of n double components. Most of the time we will be using the basic vecin, since floats are sufficient for most of our purposes. Components of a vector can be accessed via vec.x, where x is the first component of the vector. You can use .x, .y, .z, and .w to access their first, second, third, and fourth component respectively. GLSL also allows you to use RGBA for colors or SDPQ for texture coordinates, accessing the same components. The vector data type allows for some interesting and flexible component selection called swizzling. Swizzling allows us to use syntax like this.
X, Y, X, X. Z, Y, W, X, 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 X.
You can use any combination of up to 4 letters to create a new vector of the same type as long as the original vector has those components. It is not allowed to access the .z component of vec2, for example. We can also pass vectors as arguments to different vector construct calls, reducing the number of arguments required. Vectors are thus a flexible data type that we can use for all kinds of input and output. Throughout the book, you'll see plenty of examples of how we can creatively manage vectors. Shaders are nice little programs on their own, but they are part of a whole, and for that reason, we want to have inputs and outputs on the individual shaders so that we can move stuff around. GLSL defined the in and out keywords specifically for that purpose. Each shader can specify inputs and outputs using those keywords, and wherever an output variable matches with an input variable of the next shader stage, they're passed along. The vertex and fragment shader differ a bit though. The vertex shader should receive some form of input, otherwise it would be pretty ineffective. The vertex shader differs in its input in that it receives its input straight from the vertex data. To define how the vertex data is organized, we specify the input variables with location metadata so we can configure the vertex attributes on the CPU. We've seen this in the previous chapter as layout location equals 0. The vertex shader thus requires an extra layout specification for its inputs so we can link it with the vertex data. It is also possible to omit the layout location equals 0 specifier and query for the attribute locations in your OpenGL code via GL get a trib location, but I'd prefer to set them in the vertex shader. It is easier to understand and saves you and OpenGL some work. The other exception is that the fragment shader requires a vec4 color output variable, since the fragment shaders needs to generate a final output color. If you fail to specify an output color in your fragment shader, the color buffer output for those fragments will be undefined, which usually means OpenGL will render them either black or white. So if we want to send data from one shader to the other, we'd have to declare an output in the sending shader and a similar input in the receiving shader. When the types and the names are equal on both sides, OpenGL will link those variables together, and then it is possible to send data between shaders. This is done when linking a program object. To show you how this works in practice, we're going to alter the shaders from the previous chapter to let the vertex shader decide the color for the fragment shader.
Okay, let's create next section. Let's say so let's do 2 triangles, optimize the make file.
2 triangles, optimize the makefile.
So let's make shaders tutorial. So shaders tutorial HPP. So let's do triangle. Hello triangle.hpp with height update. So I think we need all of this stuff. I guess we need everything. So let's look at the init. Maybe we can get rid of a bunch of init stuff. I think we can get rid of that stuff. So we can move it. Yeah, I guess we can move it to the main.cpp. I am not sure why there is a render frame here. So let's do it this way. Include natives.hpp. And here we do shutdown. Shutdown. So we need to put it in the scope so it would not do shutdown in reverse order. Let's see. Natives. Get natives. Okay, so it's still working. I want to add the key down e done equals done or e dot still key event, key down event. keyboard event key sum equals SDL key Q SDL Q key SDL oh, and doesn't like key sum, huh? Dot key sum. Oh. Key code, SDL key code. Oh, SDL key, I see. SDL key underscore Q. Something like this. Key sum. Like this. Yeah. Yes. Took forever. No, it's cannot do it this way. It's okay. Okay, so now hello triangle. Now we can, I guess, what I would do, I would copy hello triangle to shaders tutorial. What? To what? Why it refuses? Shaders tutorial. So substitute hello triangle to shaders tutorial. Okay. So this is an incognito namespace, so we should be good. No. Oh yeah. So let's see if it's gonna work. Ah, now I need to update main. Okay. So now we are trying to make vertex shader, fragment shader. So let's shaders tutorial, fragment shader, shaders tutorial. Okay, and shaders tutorial CPP. We'll do shaders tutorial, shaders tutorial. Okay. Now let's update the shader vertex color. Vertex, so update it like this. Output vertex color, a position, okay, and this one we update in. Okay, so fragment shader, input vertex color, right? But we need to update as well varying, and it should be vec for vertex color 0. Color 1 cannot open include file. Vision shader. Interesting. Do I need to do this thing? I don't think I need to do this thing. So let's remove this stuff. Okay, so undefined variable vertex color. Color 0. Fail to compile undefined variable vertex color. Vertex shader, fragment shader, shaders tutorial, vertex color. So let's see. F5. Shaders, shaders. Shader compilation is failing with the error.
Shader compilation is failing with the error.
Change to color 1. Okay, so it says I need to remove this thing. Maybe I should change it to a color. Vertex shader tutorial. I do not understand exactly why it is like this. No. Same error. No, that did not help. GL frag color. It should not contain GL frag color. Undefined variable a color. It was an extra semicolon in dollar output directive issue.
It was an extra semicolon in the dollar output dereference issue.
Okay. Dark red. It should be dark red now. Yeah, it is dark red, but let's me shaders tutorial CPP. So let's me free try list, and let's do triangles. Tries. What it should be? Try strip. Okay, so let's center it as well. Okay. So now we can pass variables, uniforms. Uniforms are our way to pass data from our application to CPU in the shader, and GPU uniforms are, however, slightly different compared to vertex attribute. First of all, uniforms are global mean.
Global, meaning that a uniform variable is unique per shader program object and can be accessed from any shader at any stage in the shader program. Second, whatever you set the uniform value to, uniforms will keep their values until they're either reset or updated. To declare a uniform in GLSL, we simply add the uniform keyword to shader with a type and a name. From that point on, we can use the newly declared uniform in the shader. Let's see if it's time. We can set the color of the triangle var uniform.
Okay, so let's see. So uniform handle, create uniform, 27 terrain. As high texture. Probably it's in common. There is a no. Oh, yeah, there is a uniform. Use scissors, mat. So we do same thing. We just specify uniform. And doesn't look like we do need to do any mapping. We just say uniform and we're good to go. Okay. Okay, so in the fragment shader, right? Fragment shader, shaders tutorial. We do uniform, our color. Should run. It does run. It's but we need to do
We declared a uniform vec for our color in the fragment shader and set the fragment's output color to the content of this uniform value. Since uniforms are global variables, we can define them in any shader stage we'd like, so no need to go through the vertex shader again, get something to the fragment shader. We're not using this uniform in the vertex shader, so there's no need to define it there. If you declare a uniform that isn't used anywhere in your GLSL code, the compiler will silently remove the variable from the compiled version, which is the cause for several frustrating errors. Keep this in mind. The uniform is currently empty. We haven't added any data to the uniform yet, so let's try that. We first need to find the index/location of the uniform attribute in our shader. Once we have the index/location of the uniform, we can update its values. Instead of passing a single color to the fragment shader, let's spice things up by gradually changing color over time.
Okay, so I would need to search again for uniform. And samples, create uniform. So as height texture. Okay. B uniform handle. BGFX uniform handle. Vertex color. Vertex color. So, and in the constructor we would need to do vertex color equals bgfx create uniform our color bgfx uniform type vec4 bgfx. Okay, and then we need to set color location 0 0 0. Oh, okay. Set bgfx set vec4 0 let me search for create uniform vec4 for that sample. UImage LOD enabled vec4 set uniform. Okay, so it is set uniform. Vertex color, and we need to put values, right? 0 f 10 f 00 f 00 f. std array dot data. So now it should be green. Triangle should be green. It's still red. Our color. Vec 4. F 0 5 F 0 0 F 1 0 F. FS shader tutorial. So it's compiled. GLFrag color. FS shader tutorial. Vertex shader tutorial. A color. Gel position. Fragment shader. GLFrag color. What the heck? So how hello triangle is going to work? They're red. Vertex shader, hello triangle, position, fragment shader, hello triangle. Yeah, it's set to red. What? It's yellow. What the freak? Let's make it orange. Halia. Orange. So now let's switch back to, what is it, shaders tutorial. It's red. Why it's red? Fragment shader. GL frag color. If I comment this thing out, doesn't do anything. Did compile. Fragment shader tutorial.bin. This compiled. So let me copy paste fs hello triangle. So this thing did work. Hey, and now it doesn't. Okay, so it's not the problem with the shader. It is the problem. Shaders tutorial in the code. Create uniform. So I'm not applying uniform. But if I would not create a uniform, what would happen? No, it's still red. So it's not problem with uniform. What difference? VS shader tutorial, FS shader tutorial. So if I make the typo here, let's put all this stuff. Yeah, it would crash. What the difference? Clearly it's running some shader. FS shader tutorial. I'm hoping it is running FS shader tutorial. Let's swap to hello triangle shader. Not found. Oh, I misspelled it. Hello. It is red. What the heck? So it's not the shader problem. What shader it's running? RGBA Z less set state, destroy vertex color. I'm so confused. Was vertex. Program. Why it's red? What I'm doing wrong? Shader tutorial. I'm so confused. I am trying to pass uniform in the shader tutorial example, but angle is red. What am I missing? So maybe something in the fragment shader, maybe in the vertex shader. So if I remove this, oh my god, what the heck? I do not understand why, but so maybe I don't know. There is some sort of conflicts. It's evil. Green. Let's put green. No, it's still black. Set uniform vertex color, our color, vec4 array. I'm assuming it's need to be static, maybe. Static green equals auto. No, it's still dark. Add input a color to the fragment shader. I removed hello triangle shader tutorial. A color from the vertex shader. Now triangle is black regardless of what I set it from the C++ code.
I removed a color from the vertex shader. Now the triangle is black, regardless of what I set it from the C++ code.
Default is triangle list. Or exactly use triangles. I don't think it's an issue, but I'll follow your suggestions, AI. Shaders. Still black triangle. Our color set uniform. Fragment shader. Be right back. I'm wondering if set uniform should go here, maybe? No. Set uniform. with star value, number of bytes. Ah. Size of float times 4. Unaligned T-cache chunk detected. Mm. Static auto color equals that thing. C data size C dot size times size of float. What the heck? Unaligned T-cache chunk detected. Malloc T-cache get back 4. I think it should be still 1. Yeah, I think it should be still 1. June 16 Max will use the numpast and uniform creation. Pointer to uniform data. Let's try different AI. So let's try Gemini. Shaders, 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 shaders. I am expecting dark green triangle, but triangle is black.
I'm expecting a dark green triangle, but the triangle is black.
What am I missing? Okay, so Gemini said I have to add this line here. Fragment shader tutorial. Fragment shader tutorial. So I need to add this line according to Gemini. And now it's red. Maybe there is a semicolon issue. Maybe I do not need to have semicolon here. Yeah, no, it does need semicolon. Have a color, however, in your vertices. You're not actually passing any data. You just need a color on waiting. Does you plan to use vector shader? Set your phone is called before submit. So let's try to do it this way. Gel frag color, a color. I added in the fragment shader, and now triangle is red. Yeah, so AI is completely lost. Shader, fader, vertex shader. Put a color equals vec4 0 0 0 1. And now it's black. Something is definitely broken here. I'm not sure I'm happy with all this stuff. I feel compiler have to yell at me, but it does not. Or maybe like on runtime the compiler is always right. Yeah, in this case it does not. It's not right. It's it should yell at me and it does not. So Now it's black. It's like a what combination? Fragment shader, vector shader. And varying definition. So it's simple A position, tail position, A position. This is uniform. And I think now it's black, right? Yeah, now it's black. I'm pretty sure I can control the color now. So let's make it, I don't know. Yeah, so now I can, so this is not being set. Our color, vertex color. Create uniform. I'm not sure if I'm happy with mat 4. Create uniform name, type and count. Uniform type. Vec 4, mat 3, mat 4. Sampler. Is it resolved? It's closed. So it feels like a bug, but it's such a convoluted bug. Does set uniform return anything? set uniform. It does not return anything. Create uniform. There is no errors, so I can put like anything and it would like not complain. It did not complain. Shader tutorial. What the heck? So I should create uniform before loading the program. So let's see if I revert this part. Still working. Oh, so there is a things are commented out. Let's not to comment it out. Gel frag color, a color. Okay, so in the they set they put this program here, so let's put same program, shader tutorial, SDL get ticks divide by green value, and we put green value here and everything zeros. Const divide by 2 plus 0.5. I'm not sure if it's working right. I don't know. Maybe it is working right. Okay. Retrieve running time and then queries location or color and form. More attributes. Get uniform location. Oh yeah, I did it already. I thought.
As you can see, uniforms are a useful tool for setting attributes that may change every frame, or for interchanging data between your application and your shaders. But what if we want to set a color for each vertex? In that case, we'd have to declare as many uniforms as we have vertices. A better solution would be to include more data in the vertex attributes, which is what we're going to do now.
More attributes.
We saw in the previous chapter how we can fill a VBO, configure vertex attribute pointers, and store it all in a VAO. This time, we also want to add color data to the vertex data. We're going to add color data as 3 floats to the vertices array. We assign a red, green, and blue color to each of the corners of our triangle, respectively.
Uniform. Okay. So we still are doing shaders tutorials, but float R, float G, float P. Attribute position float at bgfx at rib color 1 color 4 vec 4 vec 3. I don't know. So let's see in our cube. What is it? Example cube. No, it's pos color vector ABRG and color 04 unit. Color 04 unit 8 uint 32 RGBA Anyways, So it's running. A pose, a color. Color has attribute position 1. Winning def. So how it's done with cube 1? Third party BGFX examples, cubes, V color 0. A color 0, V color 0. Okay, and vertex shaders tutorial. Vertex tutorial, a position, a color, vertex shader, a position, a color. This is vertex shader, right? Why A and V? A position, a color 0, a color 0. Have to change fragment shader as well, but they did not change it. They didn't. I think it's a typo. Ah. Our color. Out vec free. I guess I can, instead of our color here, vs fragment shader, I can just put v color. Fragment shader, shaders tutorial. So I can put $, input, v color, and set the v color here. Fail to compile, undefined variable a color is 0. Fail to compile. Oh, v color. So v color is 0 as well. Vertex shader, v color 0. Fail to compile, v color 0. Fail to compile defines v color 0. But it's red. A color 0. So let me see if I can vec for 0, 1, 0, 1. Okay, so a color 0 doesn't do anything. Oh, no, 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 no. It does do. Okay, so let's close all this stuff. Let's go back to shaders tutorial. So it is truly ABRG, ABGR. Yeah. RG B. Huh? Okay. making small step at a time. Small steps. I guess I can as well pass uniform. So let's do fragment shader. What is the name of uniform? Our color. And let's just multiply. Undefined variable our color. Our color. Undefined variable. Color 1. Fail to compile. Undefined variable. Line 20. Fail to compile. Line 20. Where is it? Oh my god. What I'm doing? Uniform vec for our color. V color 0. What? What's going on? Why now it's failing? Oh, did I? Ah, wait a second. I think I know. Semicolon. Okay, so and 1 1. Okay. Oh, let's make the commit. Vertex colors.
Vertex colors.
Okay, let's see if my previous shader tutorial hello triangle, let's see if hello triangle is hello angle. Yeah, hello triangle is still working. So we are we are only two. Let's cube one is broken, so include, what is the name, cube example cubes. Yeah, it is broken. Let me fix it. Example cubes. So it would take this width and height. So I think we can move this thing here, like this. We do not need shutdown, but instead of shutdown we would have destructor. We do not need those things. Make it everything private here. And we do not need this. No need for this. With height. Non-constant from type into. Let's do int here. Out of line shutdown. So instead of shutdown, we would do example cubes. Should not return a value. So let's see. Yeah, does work. Segfall. We should not do this shutdown. Good. Okay. Okay, so load program, load shaders. So this stuff we can remove as well. Include load program.hpp. No. Yeah, let's skip it. Post color vertex. Let's post color vertex. So I realized it should be pairs example. So no need it. It's gonna initialize by itself. Was color vertex. Oh, name space. Here we go. It will complain about init missing. Yeah, looks good. So those things should go now. fix example cubes. Okay, next. Our own shelled shader class.
Writing, compiling, and managing shaders can be quite cumbersome. As a final touch on the shader subject, we're going to make our life a bit easier by building a shader class that reads shaders from disk, compiles and links them, checks for errors, and is easy to use. This also gives you a bit of an idea how we can encapsulate some of the knowledge we learned so far into useful abstract objects. We will create the shader class entirely in a header file, mainly for learning purposes and portability. Let's start by adding the required includes and by defining the class structure.
Adjust vertex shader so that triangle is upside down. Yeah, let's do exercises because it feels like I'm still struggling. So shaders tutorial. So let's do shaders tutorial. I was too fast. Okay, so we have triangle. Let's make it upside down. So to make it upside down, we can do it this way. Interesting. Today I learned 0, 5. So we have a triangle. Oh, upside down. Yeah. So I'm glad I'm doing two exercises. Specify horizontal up offset via uniform and move triangle to the right side of the screen on the vertex shader using this offset value. Okay, that's interesting. So shader tutorial, vertex shader, we should specify uniform float offset and plus vec4 offset 0, 0, 0. Okay. And let's see if nothing is broken. Nothing is broken. And we would say bgfx uniform handle offset create uniform of set equals bg. fx create uniform of set bgfx uniform type float. What kind of types we do have? So there is no float. There is only vec 4. Okay. bgfx destroy offset and set uniform set array 1 point. It doesn't work. Set uniform. So let's see. Vertex shader. So let's call it vec4, and we can just do like this maybe. Is it too fast? Oh, it is too fast. Huh. Okay. So what is the next? Output the vertex position to the fragment shader using out keyword and set the fragment color equal to vertex position. Output the vertex position to the fragment shader using out keyword and set the fragment color equal to this vertex position. Bottom left side of the triangle black. V color 0 equals GL position. Okay. Let's do chapter 7, textures. Oh man, we are making very slow progress in learning. There is so many issues. Oh.
We learned that to add more detail to our objects, we can use colors for each vertex to create some interesting images. However, to get a fair bit of realism, we'd have to have many vertices, so we could specify a lot of colors. This takes up a considerable amount of extra overhead, since each model needs a lot more vertices, and for each vertex, a color attribute as well. What artists and programmers generally prefer is to use a texture. A texture is a 2D image. Even 1D and 3D textures exist used to add detail to an object. Think of a texture as a piece of paper with a nice brick image, for example, on it, neatly folded over your 3D house, so it looks like your house has a stone exterior. Because we can insert a lot of detail in a single image, we can give the illusion the object is extremely detailed without having to specify extra vertices. Next to images, textures can also be used to store a large collection of arbitrary data to send to the shaders, but we'll leave that for a different topic. Below you'll see a texture image of brick wall 1 mapped to the triangle from the previous chapter. In order to map a texture to the triangle, we need to tell each vertex of the triangle which part of the texture it corresponds to. Each vertex should thus have a texture coordinate associated with them that specifies what part of the texture image to sample from. Fragment interpolation then does the rest for the other fragments. Texture coordinates range from 0 to 1 in the x and y axis. Remember that we use 2D texture images. Retrieving the texture color using texture coordinates is called sampling. Texture coordinates start at 0, 0 for the lower left corner of a texture image to 1, 1 for the upper right corner of a texture image. The following image shows how we map texture coordinates to the triangle. We specify 3 texture coordinate points for the triangle. We want the bottom left side of the triangle to correspond with the bottom left side of the texture, so we use the 0, 0 texture coordinate, the triangle's bottom left vertex. The same applies to the bottom right side with a 1, 0 texture coordinate. The top of the triangle should correspond with the top center of the texture image, so we take 0.5, 1.0 as its texture coordinate. We only have to pass 3 texture coordinates to the vertex shader, which then passes those to the fragment shader that neatly interpolates all the texture coordinates for each fragment. The resulting texture coordinates would then look like this. Texture sampling has a loose interpretation and can be done in many different ways. It is thus our job to tell OpenGL how it should sample its textures. Texture coordinates usually range from 0, 0 to 1, 1. But what happens if we specify coordinates outside this range? The default behavior of OpenGL is to repeat the texture images. We basically ignore the integer part of the floating point texture coordinate, but there are more options OpenGL offers. Each of the options have a different visual output when using texture coordinates outside the default range. Let's see what these look like on a sample texture image, original image by Holger Resend. Each of the aforementioned options can be set per coordinate axis S, T, and R if you're using 3D textures equivalent to X, Y, Z with the GL text parameter function. The first argument specifies the texture target. We're working with 2D textures, so the texture target is GL texture 2D. The second argument requires us to tell what option we want to set and for which texture axis. We want to configure it for both the S and T axis. The last argument requires us to pass in the texture wrapping mode we'd like, and in this case, OpenGL will set its texture wrapping option on the currently active texture with GL mirrored repeat. If we choose the GL clamp to border option, we should also specify a border color. This is done using the FV equivalent of the GL text parameter function with GL texture border color as its option where we pass in a float array of the border's color value. Shaders chapter exercises.
Okay, so let's do textures. Um, okay, so let's do textures. Um, mm, 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 mm. Examples: cubes, remarch mesh. Remarch mesh. Instancing bump. Okay, so there is a texturing in this sample. Create texture. So this is uniform. Texture uniform. Texture color. Destroy. Set texture. M texture color. M texture. Load texture. Load texture. Load texture. Common utils. They love really long lines. Image parse, image container. Data size file path. Oh, there is a load function. Oh, just reading directly in the memory. Reading directly in the memory. In DSS format. Yeah, I think I should follow this tutorial. Hmm. So, I guess let's first make it work. So there is a load and load here. So let's get the data. Image parse. Image container. Memory. Call texture size. Cube map depth. And there is a create texture. One thing which is confusing me, it's uses DSS. DDS. Let's see. Example assets. So those one are PNGs. Runtime. And these ones are DDSs. What is DDS format? Direct show surface format. Compress. So I think for now I can load DDS file. No man, the progress is so slow, everything is scrolling. I thought I will blast through it, but there is so many small things, and spending too much time in debugging stupid issues. There's like this thing, image loading. It's like, why this one is PNG, DD map PNG. So let's see how it's been loaded. Mmap. Huh? Dmap. Dmap. Path and scale. Path to file. Image load. Image parse. This looks like it can handle it. Image container. So B image can load images. Is it leaking? Is it leaking memory here? It is leaking memory. It does leak memory. Oh man. Getting pretty tired. So did not get even to the lighting and over stuff. Man, so slow. Oh. Okay, I think I'll take a break. Getting tired. It's even hard after lighting. It and the problem right now, the problem is not it's hard intellectually. It's just so many moving parts just to piece things together. There is like a nothing complicated about stuff. It's just like a how to load texture, and this framework, this library has the libraries to be able to parse like a PNG textures, like all this stuff, and it's like and all this codes, 1,000 lines of C++ code and plus shaders. Oh, shader is quite small. Oh, there is a compute shaders as well. Oh my god. I think it's even more. It's not 1500s. How many lines of secant to draw triangle in using Vulkan?
How many lines of C code are required to draw a triangle using Vulkan?
Huh. It's not bad. $1,500. It's not bad. If it's 1,500. I doubt it's 1,500. CD project, no engine. What is the tool? CLOC. CLOC star. Star.cpp, star.hpp, star.cs. What? 700 lines of code? No way. There is no way there is a 700 lines of code. Really? Huh. That's pretty good. I'm impressed. BG, what the name of the library? BGFX is a pretty good library apparently. I'm not very happy right now with it, but I guess there is something which questionable. I do not know like why they go with that decisions. It's like uniforms. I probably would be leveraging C++ type system, because and like explicit initialization and destruction questionable. I do not know why we need to destroy it explicitly. But also in the code I could see like inits and stuff. This is kind of C style, and you have a danger to leak, which we do not want to leak. Oh yeah, with uniform, spending so much time just learning, you have to create uniform before loading the program. If you create uniform after loading program, nothing would work. Anyways, I think I'll take a break and we will try to figure out how to load textures. It doesn't look complicated. It looks like a library supports images, so we would be able just to use it. I need to figure out how not to leak the memory. I mean, first of all, I guess make it work and just slap the texture to the triangle, and then figure out the way how to not to leak memory. Anyways, we'll take a break, and I maybe will stream little bit today as well after I rested, because tomorrow is working day, and as soon as I start working, I don't think I will have too much energy studying graphics, 3D graphics, and I want to see how hard it is. Currently it's not hard, it's just cumbersome. There is just all small pieces you have to wind together, but like right now there is no introduction to math and stuff, so it just I think poorly designed stuff, because there is nothing complicated here. It's not complicated. It's complicated just because it's set up this way. Okay. Hopefully see you later. Bye.